Welcome to part 1 of the Finding Common Ground webinar series. This webinar series addresses key topics about farming and beekeeping. The first video is about how to balance risks when deciding when or how to manage pests. My name is Teresa Syra. I'm a postdoc at the University of Minnesota, here to talk to you today about how farmers and beekeepers can manage pests with a plan. All of us have to deal with pests at some point in our homes, yards, farms, and beehives. Any living organism that becomes inconvenient to human health, comfort, economics, or aesthetics because of their location and/or numbers is considered a pest. Managing pests can be a persistent and difficult problem, but scientists are working hard to help you make the right management decisions for your specific pest problems. After World War II, pest management changed drastically with the availability of new synthetic pesticides. However, this management strategy did not work for long. Pests became resistant or immune to the new pesticides. Synthetic pesticides disrupted natural biological control and contaminated the environment. Because of these problems, scientists proposed an integrated management approach to stop relying on only one management tool and use synthetic pesticides more wisely. The integrated pest management concept grew and spread and is now used in the military, schools, homes, and apiaries, and on farms. This video is focused on IPM for beekeepers and farmers. Integrated pest management, or IPM, takes a science-based approach to determine how and when to manage pests. IPM strives to minimize risks to both economic costs and human and environmental health. So how do farmers and beekeepers practice IPM? Practicing IPM includes monitoring for pests, identifying creatures that are found, and managing pests when appropriate. Monitoring for pests is done on a regular basis. Scientists study the best ways to monitor and sample for pests based on pest behavior and biology. It's important to monitor for pests to know when they arrive and to track the pest population growth over time. This way, crucial management decisions are based on the specific conditions on a farm or in an apiary. Often, low levels of pests do not threaten the health of crops or bees, and no negative outcome is associated with their presence. Those levels are considered acceptable. Pest presence becomes unacceptable for farmers and beekeepers when pest numbers reach levels that cause profit, yield, or hive losses. The dividing line between acceptable and unacceptable numbers of pests is called the economic injury level. To avoid entering the unacceptable region, management is needed before the economic injury level. To prevent pests from reaching the economic injury level, beekeepers and farmers use economic thresholds, sometimes referred to as action thresholds. The economic threshold is a guide for understanding when pests need to be managed to prevent them from reaching unacceptable levels. When management is appropriately timed, pests do not enter into unacceptable territory, and chemical management is not used unnecessarily. Managing pests when they are or would remain in the acceptable range results in unnecessary time and money spent on management and can lead to pest resistance, disruption of biological control, and environmental contamination. On the other hand, if pests are not managed until they have long been at unacceptable levels, irreversible losses may have already occurred to crops and bees, such as reduced yield and the spread of pests and pathogens to other fields or hives. You can learn more about the risks to honeybees of waiting too long to manage varroa mites in the Varroa Destructor on the Move talk in this series. Using IPM and thresholds, farmers and beekeepers find the sweet spot for management and can balance the risks and benefits of management in the most economically, socially, and environmentally sustainable way. Beekeepers monitor for varroa mite pests using a powdered sugar test. You can learn more about varroa monitoring and management in the Managing Varroa Destructor with a Plan video in this series. Similarly, farmers monitor soybean aphids on soybean. They know that managing aphids before there are 250 aphids per plant is unnecessary, and they would be spending money on insecticides for no return on their investment. When monitoring, many kinds of creatures may be found. Critical to good management is being able to accurately identify what you find. Not all the creatures you will find are bad. There are millions of species of insects out there, but only about 1% of them are pests. Some creatures are even beneficial to management of pests. Natural enemies are those creatures that kill pests. Being able to tell the difference between a pest and a non-pest is pretty important. One of these stink bugs is a pest, and the other is a natural enemy. Farmers need to look at the size of the bug's mouth parts, which are held along the belly, to determine whether they have a natural enemy that they can thank or a pest to manage. Many identification guides, websites, and apps exist to help you identify pests, and you can always contact your extension agent or professors at the university for assistance. After monitoring and identifying what is present, IPM guides farmers and beekeepers how to manage pests. Management using only synthetic pesticides didn't turn out so well, so IPM uses multiple complementary management tools. 4 general categories of management tools include cultural control, chemical control, biological control, and physical or mechanical control. Biological control involves the use of natural enemies to attack pests. Predators such as lady beetles, wasps, and spiders eat pests. Parasitoid wasps lay eggs in or on pests to parasitize and kill them, and microorganisms, such as fungi, colonize and kill pests. Cultural control reduces survival of pests by preventing their establishment, reproduction, or spread. A farmer can use plant varieties that have been genetically engineered or traditionally bred to be unappealing or resistant to pests, and a beekeeper, likewise, can use pest-resistant hygienic bees to reduce pest establishment. To limit the spread of varroa mites, beekeepers increase the distance between apiaries when possible, and farmers practice crop rotation to keep pests from persisting in fields. Physical or mechanical control keeps pests away or kills pests directly. Baited traps can attract and kill pests. Mesh and plastic barriers can prevent pests from reaching crops. Trap crops, such as sunflowers, draw pests away from crops. And using drone comb to attract varroa mites allows beekeepers to remove and destroy the mite-infested drone comb, reducing varroa mite numbers in hives. If, after using all the previous methods, pests still reach the economic threshold, chemical control is used. Chemical control commonly includes synthetic and organic chemical insecticides, miticides, and fungicides for farmers and beekeepers alike. Pesticides available today are different from the synthetic pesticides from the mid-century. Many have reduced risks to human and environmental health. Ultimately, farmers and beekeepers use IPM to make management decisions that reflect their personal values, and the decisions are based on their specific pest problems. Science and research gives them the knowledge to weigh the costs and benefits of management options, with information on how to monitor, when management is most beneficial, how to identify pests, and which management tools are effective. Integrated pest management helps farmers and beekeepers practice good stewardship of the environment and human health, and make choices that are economically sustainable.